why don't you get out a sheet of paper? We're going to do a daily activity. One of our activities here that you're going to write out and hand in when you come to class. Okay, so let's say you're a researcher and you want to know, does caffeine affect the amount of sleep that someone has? Okay, so you could do a correlation study, you can do an experimental study. So what I want you to do is just do your best to answer these questions. And they're a little open-ended, so what I'm saying here is just write out, what would a correlation study look like? You know, so kind of write out a table like this. You know, write out a table like this and explain kind of what's going on, label the table. So if you want to know, is there a relationship between the amount of caffeine and the amount of sleep? Okay. So if you do a correlation study, what would it look like? And then just use 5 observations. Just make up some hypothetical data. Okay. And then I want you to answer this question. Does the correlation study show a cause and effect relationship? Why or why not? Now you're going to do the same thing with an experimental study. Kind of write out what it would look like, make up some data. And then what would the independent and dependent variables be, and what would some possible confounding variables be? Okay, so go ahead and press pause and take some time to work on this. Okay, so hopefully you're done working on this and we can take a look at this, okay? So if you wanted to do a study, does caffeine affect the amount of sleep that you get, okay? So if you were doing a correlation study here, it would look something like this. Okay, you would take a sample of 5 people, and you would, for each person, you would look at 2 variables. You would look at the amount of caffeine they have, and then the amount of sleep that they get. Okay, and then you would record for 5 people the amount of caffeine that they have, and then you would record how much sleep they get. Okay, and you have to be careful. Amount of caffeine, you wouldn't want to say like 5 sodas or 2 cups of coffee, because different sodas have different amounts of caffeine, different coffees have different amounts of caffeine. So if you were doing this study, you would probably have to get like everything the person ate, and you would have to find out how many milligrams of caffeine was in that particular food. So any way that they could get caffeine, you would need to convert to like so many milligrams of caffeine for each one, because then you can compare that, the amount of milligrams. Okay, and then this would be, the number of hours of sleep that each person got, and you would look to see if there's a relationship. I would order these from least to greatest. And what I'm probably wondering is the amount of sleep going down. So as these increase, does the amount of sleep get less? Okay? And if it does, it means that there's a negative correlation between the variables. Okay? Now the question is, if you had a negative correlation between the variables, would that show a cause and effect relationship? Why or why not? Okay, and the answer is no, it would not show a cause and effect relationship. Okay, and the reason is because a correlation study does not show causation. Even if you had 100 values here and here, it wouldn't mean that there's a cause and effect relationship. Think of the churches and the violent crimes. If I did a sample of 100 cities and the relationship was still a correlation, it doesn't mean that there's a cause and effect relationship. It's just a different sort of relationship. So the correlation study cannot show causation. So the answer to this 2 would be no. So now, what does an experimental study look like? Give 2 treatment groups and give some hypothetical data. So, and here, I can go ahead and I can write it on here. So if I had two treatment groups, I would, have two groups like this. And what I do is I normally, if it's a correlation study, I kind of write it like a table like this. And if it's experimental, I put it in a box. It doesn't have to be that way. It's just how I've kind of always done it. Okay, so an experimental study, what you would have is have two treatment groups, and maybe this group you would have 0 milligrams of caffeine, and this group maybe they would have 500 milligrams caffeine, and I don't even know if that's reasonable, but let's just say 0 milligrams and 500 milligrams of caffeine. Okay, and then at the end of the study you would observe for 5 people how many hours of sleep each person got. And you would do the same with this group, the number of hours of sleep. Okay, and then at the end of the study, you're going to see, is there a significant difference between the two groups? So in particular, I'd probably see, is this significantly higher? Did they get more sleep than this group? And if there's a significant difference, then I would say I have evidence that the amount of caffeine does affect the amount of sleep. Okay? So now it says here, what is the independent and dependent variables of the experiment? What would be some possible confounding variables? So the independent variable is the amount of caffeine. It's the thing I want to show as the cause. Okay? It's the variable that I manipulate between the two groups. Okay? And then the dependent variable is the number of hours of sleep that they got between the two groups. And so that's the variable that I compare at the end of the experiment to see if a significant difference exists between the two groups. Okay? So what would some possible confounding variables be? So a confounding variable would be anything that would affect the amount of sleep that they get other than the caffeine. So it could be maybe how stressful their life is, how stressful their job is. It could be any other medications that might affect the sleep. It could be just anything other than caffeine that would affect the amount of sleep they get. Another interesting thing here is when you administer the treatment, the caffeine to the groups, what you would probably want to do, I'm not sure how you labeled this up here, but maybe you said something like 0 cups of coffee, 5 cups of coffee, or something like that, or 1 Mountain Dew, 10 Mountain Dews. I'm not but I'm not sure how you administer the caffeine, but the best way you would want to do it is you would want to have some sort of pill that looks identical between the groups. And one pill would be like a sugar pill or whatever. They call it a placebo. Okay? And it wouldn't have any caffeine. And then the other pill would have 500 milligrams of caffeine. And the point here is you have real control over how much caffeine each group gets. And also you eliminate another possible confounding variable. And that is that if someone is in the group that has the caffeine, just knowing that they're in the group might affect their mental state, which could affect their sleep. They call that the Hawthorne effect. When you're dealing with humans in an experiment, having the knowledge that you're in the treatment group might cause a change in the dependent variable here. Okay? And the way that you eliminate that, and they call it like a blind experiment or a double-blind experiment, is where neither group knows if they're getting the treatment. Okay? But the idea here is each group gets a pill, and neither of them know whether or not it's the caffeine pill. Okay? And so that is not a factor in the amount of sleep that they get. They call that a placebo. Okay, and a placebo is to help eliminate I think that might need to be an I, to help eliminate the Hawthorne effect is what they call it. Okay? And there you go. So that's an example of a correlation study and a experimental study dealing with answering the question, does the amount of caffeine affect the amount of sleep? So let me show you one other example. This is an example I like because it kind of combines everything that we've talked about up to this point in one example. So it's a real nice example here. So let's say you're interested in seeing if a new teaching method is effective. Or which of two teaching methods are effective. So let's say these are like reading methods to teach reading or something, and you want to compare the two methods. So you got to gather some data together. So the population you're interested in is all first grade children who are learning to read. Okay, and you're going to draw out two samples. Okay, and these will be like two treatment groups. So we're going to do an experiment. One sample is going to be taught by method A, and the other one will be taught by method B. Okay, and the idea here is you're going to try to keep anything that would affect their reading scores identical between the two groups, except for the teaching method. Okay, and then the second step here is you're going to gather data. And the data is going to be scores that they get on their reading scores. Okay? And so you're going to have to organize that data, because you could have 1,000 people in each sample. If you're doing an experiment, it's not unusual to have that many observations in your sample. And that's like the original data set I had of college tuitions. There was only like 1,200 people, or 1,200 observations in that data set. But it was huge. We had to organize it before we knew anything about it. So you would have to organize their reading scores. Okay? That is descriptive statistics. You're going to organize, simplify that data so that you understand what's going on. You can find the average values, you can make a histogram, and then you can compare the two data sets. So that's the descriptive statistics. And now the inferential statistics is interpreting your results here. And I really like the way that it puts it here, is that in doing the inferential statistics, what you're doing is you're trying to decide between one of these two interpretations. One says that there is actually no difference between the two teaching methods, and the sample difference is due to just chance, to just sampling error. Maybe we got some smarter children in one group than in the other, okay, or whatever. You know, it's just chance. The difference doesn't really mean that there's a difference in the teaching method. The second interpretation would be looking at this. We would say there really is a difference between the two methods, and the sample data accurately reflects that difference. And then it says down here, the goal of inferential statistics is to help researchers decide between these two interpretations. Okay? So is there a significant difference here? Well, you either say no. Well, there is a difference, but you say, you decide, no, I think it's not a difference in the methods. It's just chance that made this difference. We can't really blame this up here. Or we say, no, this difference is so big, it wouldn't be expected. It wouldn't be just chance that would make this difference. It must be a true difference in the teaching methods. And the inferential statistics is going to use the laws, mathematical laws of probability and the chances of getting certain differences in order to answer that question, in order to decide which of the two is the better interpretation. Okay, so that's a nice example, and it shows an experimental study. It shows how descriptive and inferential statistics would play a role in an experimental study. Okay, So, nice example.